Okay, hello everyone. So in this video I'll be discussing on interpretation of phase diagram. Again, these are all related videos, so without following the construction of phase diagram you cannot understand this. So please refer to that video and get back to this. Okay, so this video is regarding interpretation of phase diagram, and in the next video I'll be discussing on problems related to phase diagrams. So if you have studied the construction, interpretation, and how a particular that is regarding this liquidus solidus curve, all these things, okay, so a general graph, how it looks. So if you have gone through all these things and the related study materials, only follow the problems. Okay, otherwise you will be completely blank, cannot understand anything. Okay, so these are all relative videos, so please follow in the same order that as I post. Okay, so this is interpretation of phase diagram. We'll discuss now. As you can see, temperature and composition graph is used. Okay, so what we do here is, interpretation means what are all the conclusions that you draw, or what are all those observations that you can differ from this graph. That is what it means, interpretation of phase diagrams. So what we can conclude are three things. What we can interpret, what we can conclude from this phase diagram are three things: phases that are present, composition of the phase, amount of each of the phase, which is found by the lever rule. Okay, that is what it means. That means from the graph I can find out what phases are present, how much percentage of the phase is there, okay, what is the composition of every phase, and how much percentage of the phase is present. Okay, I know it's a bit confusing. When I explain it, you'll understand it clearly. Okay, so firstly we'll go with phases that are present. What does that mean? Now get back to this graph. It says we can find out the phase present from this graph. Now we are seeing this graph. How will you find the phase? We can find the phase depending upon the temperature and composition. Now say for example at 60% copper and 40% nickel at temperature of 1400 degrees Celsius, I want to predict the phase. How will I find out? I am repeating again. Composition is 60% copper and 40% nickel at the temperature of 1400 degrees Celsius. What is the phase of the composition? So if you can see, 60% copper, 40% nickel composition at the temperature of 1400 degrees Celsius means when I point it, it is liquid phase. So from the graph I can find out what is the phase if I know the composition and the temperature. That's all it means. Clear? Similarly, same combination at 1200 degrees Celsius, same composition at 900 degrees Celsius. That's all. Okay, so from the graph I can predict the phase. That is what it means. Okay, so this is the first conclusion. Second conclusion is composition of the phase. Now what does that mean? For that, you see here, I want to know the composition of every phase. Okay, same graph, the same thing is, everything is mentioned here. And one more thing, one more observation. You have in the leftmost corner, if you can see, it's 100% copper, and in the rightmost corner it is 100% nickel. What we mean to say is, and the combination you can see, 80% copper means 20% is nickel, 60% copper means 40% nickel. So the combination of these two, it results in 100%. That means what we mean to say is it's a pure binary phase. There are no other metals that are included. Discussion is only between copper and nickel because it is a binary phase. Okay, so all the diagrams and the problems that you are referring to is all binary phase. Okay, so that is one advantage, it's easier to understand. Okay, so when you are making the graph also, please make sure the summation gives you 100%. Okay, 80-20, 90-10, 60-40, 50-50, 40-20, 20-80, 0-100, like that. The combination should be 100. Okay, fine. So composition of each phase. Composition of each phase means how much percentage of copper, how much percentage of nickel is present in a particular phase. Now say, for this you just need to know the phase, you don't need the temperature. Okay, from that itself you can find out the composition of that particular phase. Okay, now say randomly I have placed point A and I want to know the composition of this phase. How will I find the composition? I know point A. I will just drop the line perpendicular to x-axis. It reads certain composition, and that is the composition of the phase. Also, if you want to know the temperature of that particular phase, just draw perpendicular line to the y-axis and you will get the temperature also. Okay, that is obvious because you know the point and you will find the temperature also related to it. But main is I want to know the composition. At this particular point, I want to know what is the composition it holds. Okay, so from this you will find the composition. Similarly, point B, I have placed point B and I want to know what is the composition, how much percentage of copper, how much percentage of nickel. Just draw a line perpendicular to x-axis and it will read. So from this graph it says that point A has 50% copper, 50% nickel, and point B has 95% of copper and 5% nickel. Okay, so that is what it means. So when you say composition of the phase, means that you are finding the composition as percentage of copper, percentage of nickel by dropping the line perpendicular to x-axis. And once you know, obviously that point, if a point is there on the graph, you will obviously know the x-axis and y-axis, right? So it's a simple thing that way. Okay, so this is composition of phase. Last one is amount of each phase. That is done by lever rule. If you remember in your physics, lever rule. Okay, but here we will be applying inverse lever rule. What is the meaning of this inverse lever rule means? Lever rule means you will be finding out the relative amount of the phase. When I mean to say amount of the phase, means how much percentage of liquid and how much percentage of solid. Again, here it is only two phase, no gaseous. Okay, you have liquidous line, you have solidus line. So it is only liquid or solid. You don't have any other phase. Okay, so you will be finding out the relative amount of the every phase. I mean, the thing is we are applying the inverse lever rule. So we are finding out the relative amount of every phase, which is directly proportional to the length of the opposite arm. That means amount of solid phase you will be finding out from the line that is coming from the liquidus curve. The amount of liquid phase you will be finding out from the line coming from the solidus curve. Understood? What it means is, if I want to know the solid phase in the particular diagram, now say for example, again getting back to the same 60% copper, 40% nickel. Okay, I want to know how much amount of phase of liquid and solid is present in the composition of 60% copper and 40% nickel. For that, I will just draw a line. Okay, temperature won't matter here. Okay, so I will draw a line till it reaches this intermediate place. Okay, that is inside the bounded curve. Okay, so I will draw a line till it reaches here. Temperature won't matter, it is okay. Okay, I'll draw a line here. I mean, I'll make a point, draw a line here, and that point I call as M, say. Then I will join that point with liquidus and solidus. Now this line what I am drawing is called as tie line. Line which is joined from this liquidus to solidus. Okay, I'll draw this line. Now from this thing I will be finding out the amount of the phase by inverse reverse rule. That is, from that particular line, the solid phase, amount of solid phase present is OM by OP into 100. Means solid phase I am finding out. So by inverse reverse rule, by inverse lever rule, line coming from the liquidus curve tells the solid phase. So OM by OP. Got it? That is what it means, inverse lever rule. OM by OP into 100. And all these numbers you will get it as usual from the graph. Similarly, if I want to know the liquid phase, how much percentage of liquid phase is present in this particular composition, that I will get from solidus curve, MP by OP. Okay, MP by OP. So finally I am getting the answer as 50% and 50%. Got it? So what it means is 50% of the composition at 60% copper, 60% copper and 40% nickel, the composition of every phase is this much. Again, with temperature also. Now say for example this holds good for 1200 degrees Celsius. Now say for example I want to know at 900 degrees Celsius. Okay, it is the same. I will draw a tie line. So basically if you want to know the amount of every phase, you should have the tie line. Okay, temperature will not matter. Again, if it will depend on the question. Now when you are solving the problems on phase diagram, their temperature will be specified, composition will be specified, depending upon the question you will be applying. Okay, so generally if you want to know, okay, temperature, of course it is on the y-axis, so obviously it will come. But if you want to know the phase, mainly you need to know the composition. So when you draw the line, all the lines perpendicular to it, okay, that is like when you know here the composition, you drew the point M, you join, and you drop the lines also perpendicular to this. Okay, so mainly you need is the tie line. So this obviously temperature will come anyways, it will be going to y-axis. Okay, so in problems they do ask like this, from the tie line also you will have to find the temperature, which is very easy. Okay, so what is the main thing is you are finding out the amount of the phase. For that you mainly require the tie line. Okay, so that is what it means. If I know it's bit confusing, but it's very simple. When you solve the problem, you will even more clearly understand. Okay, so this is interpretation of the phase. Again, I will tell you, interpretation is nothing but what are the observations or what are the conclusions that you are drawing from the phase diagram, especially a diagram which has temperature and composition graph. What are the conclusions? So these are the three conclusions: what phases are present, what is the composition of every phase, and what is the amount of every phase. Got it? So these are the three observations or conclusions that we can draw. Okay, this is quite important, because based on this interpretation of phase diagram only our rest of the problems will be solving. So if you have not understood it much clearly, please reverse the video and please understand it. Okay, I have told it in very simple way as much as possible. If you have still not understood, please let me know. Okay, so based on this interpretation of phase diagram, construction of phase diagram, only the entire problem solving goes on. So the next video when I am solving the problem, you should be referring the interpretation and the construction of phase diagram. Without these two, you cannot understand the problems. So please follow these videos and then get back to the problems. Okay, so next video I will be covering 2 problems on phase diagram. Okay, so that should be helpful to you. If you find any difficulty with any other sort of the problem, let me know. I'll explain that problem also.